Hello everyone, this is Alex Designman. In this video we are going to make a drawing using the flattened harness that we did in the last videos. So if you're just clicking on this video and you don't know where to start, you need to go back at the part 1 of the Catia V5 electrical harness design video series. So you need to do that first, and after that you go to the Catia V5 electrical harness flattening video series. So this is the flattened harness that we did in the last video. And this is the project harness where we started to do the flattening. So the first thing we need to do to start here is to create a new drawing. Here, let's start with an A0 format, which is the biggest format. We need to make the first projection, and after that, we are going to adjust everything. So here, let's make the first front view. So this is the drafting, Catia V5 drafting workbench. If you want to learn this whole workbench, take my Catia V5 course that will take you from beginner to advanced in Catia V5. So you can find that course on my Udemy page. There is a link at the description of this video, and also a link to get in touch with me on LinkedIn in case you need a discount coupon code for the course. So if I click on this command, the software says select a reference plane on a 3D geometry, and we need to switch now to the 3D project, but not this one, the one that we want to project on the drawing, and that's going to be the flattened one. And here we need to create on a surface, on a plane that we want to see. So if you want to see the harness like this, I'm going to pick a surface. You can have planes, or I can just pick this surface from this connector. And on here we pick this green handle, and I can rotate this, and then I click outside, and here we have the harness on the drawing. So if your harness does not fit on the drawing, you need to do a few adjustments. So this is the adjustments that I did on the 3D flattened harness. I used the scale command that I showed in the last video, and I scaled those branches. So this one, which is from here to here, I scaled it down to 350 millimeters. Then I took those branches down to 100 millimeters. You can see the difference here. So you will also see the difference on your project if you try this. And then this one from 1082 to 900. So this is long from here to here. So it's not only this branch. So the flattening workbench does not recognize those branching points. It just sees the whole branchable. So that's another issue with this workbench and why many companies do not use it. And you're going to see that the retainers, they remain kind of outside of the harness. So also this workbench does not recognize retainers. So it's very limited from this point of view. That's why I say all the time that a lot of companies do not use it. Scale, also this branch. So this can go down to 200. So this is very long, if you remember well. And once you did all of those, everything is going to be updated. And you go here and you update selection. Let's make this text a little bigger. So now before we add other elements on the drawing, first thing that we need to do is to go on edit, sheet background, so we can add a title block. And here we have this toolbar, and there is a command here called frame and title block. From here we choose one of those models. When you work in a company, you might have more models that they added, but those are some standards that everybody uses in general. Click OK. The frame and the title block are now installed. You can see it right here. And if you want to modify this, you need to modify each text individually. Also, I worked in companies where they had like a script. So you would write, so a window would appear in the middle of the screen, and you'll write all of those elements and they will be automatically updated. So it's not necessarily needed, but each company, they have their own standards. And in case they don't, this is how you do it manually by default in Catia V5. Another thing that we can add here is going to be the bill of materials. So to do that, first, we're going to take a look in the project file, so the original project. So you remember in the other videos, I was saying that the product for the harness needs to be dedicated. It has electrical properties that we added here. You can see the icon. Has inside the multi-branchable, one or more than one, depends how you want to organize them. And then it has the elements of the harness only. So that's going to be connectors, that's going to be retainers, and other things like maybe protective coverings, maybe some plastic channels. So everything that it's in the bill of materials of the harness needs to be here in this product. So now if you go on the drawing, here we have the command for bill of materials. Click on it and it says for select the source cut product document. So we go to the 3D project and we select the dedicated cut product. Click on it. It automatically takes you back and creates the bill of materials. You need to click where you want to insert it, so it's going to be here in this empty space. Here we have it. So this is going to be in the background, so if you want to edit this, you can edit this now. The multi-branchable, for example, doesn't have to be here because this is not a physical component, the multi-branchable. There is no multi-branchable in reality, that's only in Catia v5. In reality, you have a pack of wires held together by tape or some other elements, but connectors, it is going to be, retainer, it is going to be, and so on. So to remove this, you will edit it like you will normally edit every kind of table in a Catia v5 drafting. Here we have the final bill of material. So let's also delete from here. So you have one connector B, 5 retainers, 5 connector A. If you want to add something, just add a new row, and inside it you can write quantity, you know, the type of part in here. You can edit, let's say you don't have nomenclature, but we have reference. So this is going to be C1, and then 5 connectors A is going to be C2, C3, C4, and so on. Okay. Revision, you can have this or not, so you can have everything you want in here. After that, if this is too small, I would make it a little bigger. Let's make this 7. You can have something like this. If you go into the dedicated product of the electrical harness, if we don't want multi-branchable to appear when we do the bill of materials, you just right click on it, properties, and here you have visualizing the bill of materials, so you uncheck this. So I forgot about this for a second. So many times, because we don't use these kind of drawings in our electrical harness design, and many times even in mechanical harness design, we just use external, just use another bill of materials. Once we finish here, we go to edit, go back to working views. Here we have it, and we can start to add stuff on the harness. So for example, if we want to add a dimension from the dimensions toolbar, dimensions toolbar is very big. Let's add a dimension, biggest bundle from this connector to this connector. So this the number, let's make it bigger, let's make it 10. Let's try 7. 7, it's okay. So by default, the dimensions are added from the back of the connector, and this is because this way you know the exact length of the harness, and then you just need to add the length of wires that go inside the connector, because each connector is going to be longer, shorter, it's going to need more wires inside, less wires inside. We also need to take the pins in consideration. So this way you know this is the length, and then you just add what you need inside here. You don't put it to the top of the connector, because then you don't know how to add those anymore, because the length inside here is still going to come from a data sheet or from an experiment that you did to see. But the length of the connector itself, it's irrelevant, because the connector inside has wires, but it also has pins. So this is the first length. Then we can add from the back of the connector to the first branching point. So we see that this line is right in the middle here. So you add this dimension, and then from here to the next branching point, and also from here to this connector here. But here we do not have a line to attach this to. So the branching point is here in the middle of the intersection of those two bundles. So more exactly, this is how I would take the branching point. So we need to add an axis line. So because this is cylindrical, it's going to detect it. So when I click on this line, it's going to add the axis line here. If not, you can just add a line between two lines. An axis line, you can add it between two lines. So I teach all of those. You see there are many commands here. I teach all of those in my course, and how to use them in all the possibilities. Then again here, so we have two center lines two axis lines that they just intersect here. So this is the branching point. So if you want to add this length, we add it from the back of the connector to this branching point here. Then we also need to add this branching point here. So if you want to add this exactly, you can add another center line here, another center line here, and do the intersection here. So it can be this. The thing is, I don't want to add too many center lines that are not relevant, because we don't need those. So you see the intersection, it's right here on this line. So I'm going to delete this because we have this intersection here. So this is I can add here a center line. This is another command. I can just go here, another dimension from this center line. It has a center point to the back of this connector, and another one from here to the back of this connector. Like this you can add all the dimensions. So this is how you add dimensions. Next, we need to add annotations for the connectors. So there are a few things here. We have a text with leader, but I like to use this balloon, for example. So this is going to be, so you see that when I hover, it says here connector B and the instance name connector B.1. It takes this from the 3D model. So you can imagine that you can take this automatically to the drawing. So in here I add this balloon, but this is manual. So this is how you add something manual. You just add a text. Let's make it bigger. C1, make it 10. Okay. And then you go C2, 3. Okay. You also have, this is the retainer here. You can add this like R1. So in my course on Udemy, I show how to use this text template placement tool to automatically take information about each part directly from the 3D model, so you don't have to write them down. And also I'll show how to use text replicate. So to add dimensions for the retainers, first we need to see the center of the retainer somehow. You can add the center line like this, but you can also do this. You can do right click on the view and go to overload properties. Here I want to click on the retainer, edit, represent with hidden lines. Okay. So now I can see the fur tree as hidden lines and other hidden lines, and I can just add a center line because it's round and it's going to detect it. Dimension, and we add from the line to the nearest branching point or to the back of the connector. So you choose this depending on your factory rules or the rules in a company that you're working for. Then you might have protective coverings from the 3D model. So let's see if we can add something. So here I added some tape, protective tape for a piece of harness. Tape simple. So this is generated by software. If you double click on it, this is a trick that I do. So this is in fact a rib from part design. And I don't like it that it penetrates with the harness. I don't like that. It can be seen on the drawing. So I just go here and I do this trick where I click thick profile and the problem is solved. Just thickness 1 millimeter. Let's tape, it's about 1 millimeter maximum. So it's not going to be bigger than 1 millimeter. It needs to be something else. Click OK. So if I save this, so there is another command to add tape where it doesn't do this issue. Okay. Harness flattened. Electrical harness flattening. Synchronize. Protective coverings. Okay. Synchronize flag. Simulate. Click OK. This is the report. I don't need this. I only want to see the tape that has been synchronized. Let's also save this one. Drawing. Update. Yeah, so this dimension needs to be deleted and changed because the line here has disappeared because the tape appeared in here. So if you go in this project here, you can see that the tape inside the electrical harness has its own part. So it's a part. The other command will insert the tape inside the multi-branchable, so it's not going to appear in the BOM. So that's the difference between the two commands, but I teach that in my Catia V5 electrical harness courses. So all the details for that and how to use the catalog, how to save stuff in the catalog and so on. So let's do this again here. Let's add this center line, dimension between connector and center line. And let's remake this BOM. So here is the BOM, delete. Let's remake it. Bill of material, go into the project. I need to click on this product. Click here. So you see the multi-branchable is not here anymore because I unchecked that. But we have this tape simple with 10mm green. This is the name from the Catia V5 catalog, but obviously they write there whatever they want. You need to write here what you have in your company, so you need to modify the catalog and write this tape or save a new tape in the catalog, and that's going to have the name of the tape. For example, this is a type of tape. Quantity, I don't know, just put here 1000 millimeters, or you can put non-available. Many times is the factory that will have to calculate the length of the tape, so you don't know that. So this is the bill of materials. Put those here. Edit, working views. Here you can say T1, which is the tape, and we can represent that in here with area fill creation. So I have area fill creation. If I click here, that's going to go everywhere because I have here a piece of line that's missing. This is how Catia decided to generate this drawing. So I need to close this with a simple line from here to here. Okay. Now when I do area fill creation, it's going to stay inside here. Double click on this and graphic pattern. Angle 45 degrees, you can change the angle of this. So if I do, for example, 0, 90 degrees, it's going to be vertical. 60, 30, you know, it's going to be inclined. Pitch, offset, this is just to play around with this. So you can have something like this to indicate tape. But you might also need like a detail view. And in here you can add specific factory stuff. In fact, I need to activate this first. So you can add a tape. And here we have some details around about this. Tape overlap 5mm and tape angle 45 degrees. So the angle of the tape is going to be 45 degrees and tape is going to overlap here for 5mm. So we can show this through dimensions, properties, value, fake dimension. It's right here 5. This is 19. So this is like a detail that can be on the drawing. You can have details like this for each instance. So you need to explain on the drawing everything that needs to happen on that drawing, because you as a harness owner, you're going to be responsible for that, or the harness owner is going to tell you that, and you're going to have to come with solution on the drawing on how to explain that to the manufacturing plant. So the drawing needs to be so perfect that there is no email or telephone communication between you and the manufacturing plant. Maybe just one call to make sure that they understand everything. So they will need to look at the drawing and say everything that you and the harness owner were thinking. So if that happens, it means you did a great drawing. So all the details, they need to be in here. If the details that are not here, maybe because they are standard factory requirements. For example, tape needs to end 5mm before the connector. For example, this is just giving you one. because inside the bundle there are wires, so there are pins inside the connector. So the first pin is going to be around here, the last one around here. So obviously the wire is going to come like this from the bundle to the connector. So this is a detail that I also teach on my Udemy courses, but there are many details that I teach in there like this, many rules. So the wires at the extremities here, they're not going to come like this. This is wrong. They need to come like this. This is good. So the tape needs to stop here, so the wires can freely travel to the connector. If you do this, if you stop the tape very close, this will create a lot of tension in the wire, and it's going to create a lot of tension in the pin that is inside here. So it can pull out the pins even. So you see, this is very steep. This is better. So each manufacturing plant has a rule that they developed in time. This is experience from their side. But usually those are not put in the drawings because that's standard stuff. That's basic stuff. That's like the 10 commandments of harness design. So I show those in my Udemy courses. I actually explain those on 3D with presentations, so I'm not just talking about them. And I show a lot of stuff in there that if you discuss about those at the interviews, they would know you know. So they would be convinced that you're the guy, the right person to work for them. So this is how you create a drawing using the flattened harness and Catia V5 drafting. But as I said, this is not the way I've seen companies doing it. This is a general way, a universal way for all industries. And in a future video, I'm going to show you specifically for automotive and racing. Maybe I'm going to do 2 videos if they're too long, if it's going to be too long, automotive and racing in one video. But I'm going to show all the methods that I've seen them using, and with softwares outside of Catia V5. I'm going also to show how to use this drafting, and also other softwares outside Catia V5 that anyone can have, anyone can get those softwares. And I'm going to explain why they use those softwares. Because the softwares, they're not the important ones, they do not matter, but the process to turn the design into a real harness, that's what matters. So I'm going to show you what they use to make that happen in a future video. So subscribe to the channel and activate the notification bell to be notified when the video is going to be uploaded. Until then, I hope this was helpful and see you in a future video.